Dealing with time. Time is extremely important to understand in Splunk. You can imagine that if you had a bunch of events that you were investigating and they had no timestamps, it would be a very confusing ordeal because you could have data from as early as 6 years ago all the way up until the current time, and it would be totally unorganized. Splunk has a specific definition of a timestamp, and it's from the Splexicon, and the link is down there at the bottom, and it is a default field that represents time information in an event. Most events contain timestamps. In cases where an event does not contain timestamp information, Splunk attempts to assign a timestamp value to the event at index time. The default time field for Splunk is _time. It's a Splunk-generated field, and it's added automatically based on patterns that Splunk attempts to recognize as time. And those patterns come from the raw event data. If there isn't an explicit time field, Splunk will try to guess which part of the data is representing time. And as a very last resort, Splunk will set the timestamp to the current system time. So there's no event left behind when it comes to time. That's how important time is. And for Splunk administrators, we can also see the importance of time in doing our SPL. Splunk uses the timestamp information for that time selector over on the right side there of the search bar. And as you can see, we have a lot of presets. We have real time, which gives us, for example, a 30-second window, and it would refresh every 30 seconds. We have relative, that's pretty self-explanatory. And we have all time. I caution you to use all time because if you have a lot of data and you tell Splunk to search something throughout all time on that data, it could go back as far as 6 years ago. And that's going to take Splunk a long time to get you any results. And it's going to be extremely resource intensive on whichever machine you are running the search on. So a good rule of thumb is pick a reasonable time range for your SPL search. Sometimes time is not in the user-friendly format that we would like it to be in. Often it's in Unix format, which if you've ever seen Unix format, it takes a little bit of internal processing by the user to figure out what time is actually being displayed. Luckily, Splunk comes with a bunch of built-in time conversion variables. And using the eval command, combined with this strf time, strf time, we can change the default time format to one of our choosing. So here's how the eval command works in that scenario. It's after a pipe because it's a command. We use the keyword eval. Then we name the new field. So in this case I've just done time, but you could do timestamp or whatever you want really. Equals, and then the keyword strf time, then parentheses, the original field, which in this case is _time, comma, and then in quotes, the variables that represent the new format of the time that you want. And we'll take a look at those on the next slide. Here are just some of the time variables that Splunk has built in for us. And they all start with percent signs. We have capital H, which will display the hour in a 24-hour clock. We have capital I, which will do the same thing but with a 12-hour clock. We have capital M and capital S for minute and second. And we have a lowercase p that will display either AM or PM. And obviously that works especially well with the capital I. We can also convert dates to the way that we want them. And of course, date variables also start with percent signs. And we have capital A for the full day name. Lowercase d displays the day of the month in number format with a leading 0. And lowercase e does the same thing without a leading 0. Capital B gives us the full month name. Lowercase b gives us an abbreviated month name. Lowercase m gives us month as a number. Capital Y gives us a 4-digit year. And lowercase y gives us a 2-digit year. Okay, pop quiz time. Suppose the time is 1:07:32 p.m. and we want to convert it. And we've used the strings on the left side of that table. And I want you to pause the video now and see if you can compute the output of that string based on the time above. Okay, are you ready for the big reveal? Capital I gives us the hour in 12-hour format. Capital M gives us the minute. And then that lowercase p gives us the AM or the PM stamp. And we can really put any marker in the middle of those. See, I have a colon there. You could have put a dash or whatever you want, really. The second one is capital H, capital M, which will give us the 24-hour hour and the minute. The third one down just adds a capital S, which gives us the second. The fourth one down is only capital S, which would only display the seconds. The fifth one down is a lowercase p alone, which only would display AM or PM. I don't imagine why you would want to use that, but you can. And the same is true for dates. So suppose the date is January 20th, 2017 at 1:07:32 p.m. and we want to convert the date and time using those strings on the left. Go ahead and pause the video and see if you can compute the output. Okay, are you ready? That lowercase d will give us the day of the month. The capital B gives us the full month name. Capital Y gives us the 4-digit year. Capital I gives us the 12-hour hour. Capital M gives us the minutes. Lowercase p puts an AM or PM marker on it. On the second one down, capital H gives us the 24-hour hour marker. Capital M gives us the minutes. Lowercase b gives us the abbreviated month. And lowercase y gives us the 2-digit year. And on the third one down, this is something you probably would never use. I cannot imagine a scenario when you would ever use alternating lowercase and capital Y's, but you could theoretically do it, and the output would be 2-digit year, 4-digit year, 2-digit year, 4-digit year. So 17, 2017, 17, 2017. Let's take a look in our Splunk search head, and using our homework data, let's take a look at how to deal with time. Here we are in our Splunk search head. Let's bring in our homework data, and remember we could either do host equals homework, or we can click on data summary and simply choose homework. And I'm comfortable leaving this at all time because I know there are only 2,000 events, so it should populate pretty quickly. And here we go. Let's look at the first event, and we'll look at the raw event data, which is here at the top. And it was very easy for Splunk to pick out the time because I included time as one of the fields in the homework data. And here is where time has been assigned, and this is a Unix timestamp. So let's create a simple table with a simple scenario that's going to have a timestamp and a username. So maybe in this hypothetical situation we want to know when a user attempted to access our system. So we'll do the pipe and then the keyword table underscore time user, but we have to include user equals asterisk because we want to include all users. And let's run that. And now we have a timestamp and a user. And the timestamp looks okay. I mean, people could probably figure out the date and the time there. But let's say that that is not sufficient. Let's play around with the time here. So remember, in between these two pipes, we're going to do an eval statement, and let's call our field timestamp equals underscore time, comma, and then in quotes, the time variables that we want to include. So let's say we want 12-hour time, a colon. Let's say we want the minute, and for right now, let's say we don't care about anything else. And we'll change this underscore time field to our new field, which is timestamp. And of course, we have to include the strftime command. Now we see the 12-hour hour marker and the minute marker, and then our associated user. And we probably also want to see the AM or PM marker. And there it is. Now let's also bring in the date, and maybe we'll put it before the time information. Let's do a lowercase d and a capital B and comma. Now, what's that going to bring up for us? Lowercase d will give us the day of the month. Capital B will give us the full month name. Then we put a comma in there. Now, just for fun, let's try my little crazy time variable evaluation that I showed you in the slides, where I simply alternated year formats. And there is that weird timestamp that doesn't really mean anything there. Those are the basics of how you deal with time in Splunk. I really appreciate you joining me in this section, and I look forward to seeing you next time. Welcome back, and welcome to Search Modes, Fields, and Field Discovery. As we've seen before, the Search app has 3 modes, and you can select the mode right under the time picker in the search bar. Splunk has Fast Mode, Smart Mode, and Verbose Mode. In Fast Mode, no fields are discovered except the default 3 metadata fields that we talked about. And Splunk assumes that you know which fields you want, and you've specified them in the search string if you use Fast Mode. Obviously, Fast Mode is fast, because you're doing the work of specifying the fields instead of Splunk's engine trying to figure out what the fields are. Smart Mode attempts to return the best results for whatever search you're running. It attempts to detect and return interesting fields. And Verbose Mode uses the Splunk engine to detect and return all of the fields. Verbose Mode is slow, but if you're not sure what fields you will want to report on, if the data set is, for example, unfamiliar to you. Okay, so Smart Mode and Verbose Mode, I said that Splunk uses Splunk's engine to discover fields. Well, how does that actually happen? During field discovery, Splunk detects fields that are key value pairs. That's what a field is in Splunk. Key equals value. So error equals failed, level equals critical. Those would be examples of fields. Error equals and then anything. That would be an example of a field. Anything equals anything. That's an example of a field as well. When we saw the field browser on the left-hand side, notice that the first 50 key value pairs are displayed there. And then it has a little drop down that says show more fields if more are available. But one of the whole points of this class was that Splunk can also deal with unstructured data where things are not always in nice key value pairs. And what if that happened? What if the data is a bunch of, well, this data is, I would say, semi-structured, but what if there are key value pairs? What if there are fields in this data, for example, that you want to extract, but that are not in nice, neat key value pairs? Well, Splunk has a very powerful and very useful field extraction tool. And it's pretty easy to use. The engine behind it works using regular expressions. However, Splunk has some tools built in to help you because regular expressions are kind of a pain to write and not everybody knows how to write regular expressions. And of course, it's beyond the scope of this class, but I will show you how to use the built-in tools with Splunk in our demo. Let's go to the Search app. And let's bring in our homework data. We could type host equals homework, or we could click on the data summary button like I've just done and click homework. We could also just type host equals homework, since when we imported it the first time, that's the host name value we gave to that data. Notice it is a key value pair. Host is a metadata for Splunk. So Splunk always brings in these 3 selected fields. Host, source, and source type, that is default Splunk metadata. And here are our search modes over here. Right now it is in verbose mode because I've only specified a host. So Splunk is thinking this person doesn't know what fields are in this data, so I better go in verbose mode and try to figure out all the fields that are available. And here we are, and the first 50 are listed here, and one more is available. And let's say that none of these fields that Splunk has found in verbose mode is a field that we want. So we can go to Extract New Fields, and this will bring us to the Splunk Field Extraction Tools. And if you're really good with regular expressions, you can write the regular expression yourself. But the first thing we need to do is select a sample. So let's select an event in our data that has the field we want. And let's just say, for example, it's this. And now Splunk shows us the event data. And we'll click Next. And we'll select Method. Now either one of these would work. Since this is a CSV file, it's still nicely laid out with comma separation. So we could use delimiters where Splunk automatically attempts to extract the fields, and you can specify which fields are which. But I want to show you this regular expression method because it does a lot better with unstructured data. So click on regular expression and then Next. And now it says highlight one or more values in the sample data to create fields. So let us say that this field, this value right here, is a field that we want to keep track of, and a field we want to use in our search, but it doesn't have a key value pair, so Splunk didn't detect it. But it's just a random numerical value, but let's say that it's important to us. So we'll highlight it, and Splunk will ask for a field name. And let's say that it is a system ID. Now it says, look through the data and verify that the right fields have been extracted. And Splunk has actually written a regular expression behind the scenes. And let's click Next and we'll validate this. Everything looks good. If Splunk has detected something that was not what we meant to extract, we can just simply click the X there. And it's sort of teaching Splunk. We'll validate it, and we'll name the extraction. I don't really care what it's named, so I'm going to leave the default. And we'll set permissions. I like to set all apps unless there's some specific reason that I am restricting access. And we'll click Finish. And we'll click Explore the fields I just created. And instead of this auto-generated search that Splunk has given us, let's go back to host equals homework. And notice that now this field, system ID, is detected, and it is those numerical values. So now we can use that field in our search. And we'll bring in all the system IDs, and let's make a simple table with system ID and maybe state. Now we can know which systems are in which state. Now Splunk stayed on verbose mode, but we could actually do fast mode on this since we've specified the fields we want and we've created a table with it. Fields and field extractions are extremely powerful in Splunk, and the good news is they're not hard to learn or to use. So I thank you for joining me in this segment, and I look forward to seeing you next time. Welcome back. Let's do some intermediate searching. Before we do that, let's just recall the search pipeline. We start out with a lot of data, and we sort of whittle it down until we get the data we want in the format we want. Remember, we start with a broad search, some sort of metadata search, like host equals my host, source type equals CSV, something like that. Then we can add in keywords, booleans, and fields, user equals B123, keywords like locked, boolean expressions like ors and ands, or nots. Then we can pipe that to some commands like count, sum, eval, and finally we can pipe that to some sort of table or visualization. The most popular transforming commands, and remember that happens there under the commands, so the second step, the most popular transforming commands are top, rare, and stats. For the top command, the syntax is top and then a field. And remember, it comes after the pipe. And it returns the most common values of a given field, defaulting to 10, but you can combine it with a limit number if you want, if you need more than 10. It automatically builds a table with two other columns, count and percent. And it can be used with multiple fields, which makes top a very powerful command. So we could return the top value for a field organized by another field, for example. Here's an example of top user, if there was a field called user. It returns the top 10. It returns the top 10 users with the highest count, and then it tells you the percentage. Another important command is rare, and it takes the same syntax, but it's exactly opposite of top. It returns the bottom 10, the least common values of a field. And we still get the identical options to top, and it still returns those additional two columns of count and percent. Stats is an equally important command to understand. It has more of a complicated syntax, but it's still quite easy. The syntax is simply stats and then a function, and in parentheses the field you want to do that function on, and then the word by, and then the field you want to organize it by. So example of some functions, count, average, max, mean, medium, things you would normally use. So we could do, for example, stats, average, if there was a field called kbps, by host. Then it would tell us the average kilobits per second by host. We could do stats, count, and then failed logins, if that was a field, by user. That would give us the number of failed logins by user. Let's take a look at these three commands in action. Okay, back to our Splunk search head, and I simply typed in host equals homework so I could bring up all of our homework data. And now I want to show you top, rare, and stats and how to use those commands. So first of all, let's bring in some fields that we think could be interesting here. And I'm going to bring in state and user. Let's say that we want to know how many users are in each state. So wildcard on state, wildcard on user, and all of the data has both of those fields, so it's still going to have 2,000 rows. Now let's do a pipe, and the first thing I want to do is the stats command and show you how that works. Now remember what our goal is. We want to know how many users are in each state. And remember the syntax of the stats command. It's the keyword stats, then some sort of function, and then the field in parentheses, and then by which field you want. Okay, now we have a statistical table that has every state and the number of users in the state. But look what it named this field, count parentheses user. That's not going to be easy to work with. So let's do a simple as C user by state. Now we have two fields, state and C user, and we have each state listed with the number of users in that state. But that's still, it makes sense, but it could be organized a lot better. So let's do a simple sort command, and we'll do a minus sign, and then C user. And this is going to sort descending, so it's going to put the highest count at the top. Okay, now we have each state and the number of users. It's sorted by the number of users in each state. And this plays extremely well into a visualization. And in fact, Splunk's going to simply create that visualization for us if we click on the Visualization tab. There we have a graph, a column chart of every state and the number of users in each state. And that could be very useful. Now I want to show you how to use top and rare. And this statistic table and even these fields don't really play well into those commands. So let's go back to our base data set. And level was our error level. So let's do error level and state. Let's say that we want to know the top 10 states by error level. So we'll bring in a wildcard for state and level. And before we do top on this, let's narrow this down a little bit so we have to do less work. So let's say we want to only know about level equals critical, because the other ones are not quite as important to know about, and we want to know which states are throwing the most critical errors. So let's do top state by level. So this shows us the top 10 states that are throwing this critical level and the count of the critical error messages that we're getting and the percent. So that could be very useful. We could also put that in a visualization. We'd want to tweak it a little bit, but we'll show you how to do that in the visualization section of this course. Now let's do the same thing, but let's do rare, so we can see the states who are not causing a problem. So Arkansas, Delaware are not really causing a problem. Actually, that's Alaska. Sorry, Alaska, Delaware. Arkansas is not really causing a problem either. It's got 2. So again, we can see a visualization. Of course, we'd want to tweak it a little bit, but notice how it's almost opposite of the visualization for top. So that's top, rare, and stats. And I really thank you for joining me in this segment, and I look forward to seeing you in the next segment.